Hi everyone, good day. Welcome back to our next video. In this video, we will be discussing about the operators in C. Let us start a discussion on operators. Consider this expression A plus B. When I say it is an expression, it is a sequence of operands and operators that reduce to a single value. Here, A and B are called the operands and plus is the operator. Operands means it is an entity on which an operation is to be performed. An operand can be a variable name, a constant, a function call, or a macro name. Operators, they are nothing but it is a symbol that specifies the operation to be applied to its operand. So here A and B are operands and plus is the operator. The plus operator performs an addition operation on the operands A and B. This expression is called as a symbol expression because it has only one operator. If it has more than one operator, then we call such an expression as a compound expression. Say for in this example, we have an expression A plus B star C. So here we have more than one operator. So this expression is called as a compound expression. Operators can be classified based on the number of operands on which the operator operates and based on the role of an operator. Based on the number of operands, the operators are classified as unary operator, binary operator, and ternary operator. A unary operator, it operates on only one operand. For example, minus 3. Here minus is a unary minus operator. It gives a negative sign for the number. Then we have the binary operator. A binary operator operates on two operands. So here in this example, we have 2 plus 3. Plus is a binary operator which operates on two operands, 2 and 3. The next operator is the ternary operator. Ternary operator operates on three operands. So the only ternary operator available is the conditional operator. So it is denoted by question mark, colon. So here, before the question mark, we have an expression E1. Followed by the question mark, we have an expression E2 and E3. So if the first expression is true, if it evaluates to true, it will select E2, and if the first expression is false, it will select E3. Based on the role of operator, they can be classified as arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and special operators. What is an arithmetic operator? An arithmetic operator includes unary plus, unary minus, increment, decrement, multiplication, division, modulus, addition, and subtraction. Any expression that involves arithmetic operators are called arithmetic expression. So let us see one example for each of the operators. So the first operator is the unary plus operator. So here consider plus 5. So plus 5 says that the number is a positive number. In unary operator, the operators are always placed to the left of the operand. Then we have the unary minus. Minus is also given to the left of the operand. Say for example, minus 3. It says that it is a negative value. Minus is usually used for negating a given number. Then we have the increment operator. Increment operator, it is used to increase the value by 1. For any variable, if we use this increment operator, by default the value is incremented by 1. Say for example, here we can write the increment operator as pre-increment plus plus a and post-increment a plus plus. So which is equivalent to a equal to a plus 1. In pre-increment, first the value of its operand is incremented and then it is used for evaluation of expression. In post-increment, the value of the operand is used first for evaluation of the expression, then the value of the operand is incremented. Then we have the decrement operator. It subtracts 1 from the operand. Decrement operator can also be expressed as post-decrement and pre-decrement. Say for example, a minus minus, which indicates post-decrement, and minus minus a, which indicates the predecrement. Next, we have the multiplication operator. The multiplication operator is used to find the product of two operands. Say for example, 2 into 3, the operator applies on the operand to give the product as 6. Then we have the division operator. The division operator, it is used to find the quotient. Say for example, if I divide 4 by 3, the quotient will be 1. So it will not take the decimal value, it will take only the integer part. As both the operands are integers, it will consider only the integer part. Then we have the modulus operator. In modulus operator, it is used to find the remainder. So in any division operation, if you want the remainder, then it can be found out by using the modulus operator. Say for example, if I have the value 4 mod 3, then again the remainder will be 1. The next operator is the addition operator. So the addition operator is used to find the sum of two operands. So it is applied to find the sum of two operands. Say for example, 2 plus 3 will give 5. Subtraction operator. Subtraction operator is used to find the difference between the two operands. Say for example, 5 minus 2, the result will be 3. So as I already told you, any expression which involves all these arithmetic operators are called as the arithmetic expression. Binary arithmetic operators can be used in one of the following three different modes: integer mode, floating point mode, and mixed mode. Integer mode, here both the operands of binary arithmetic operator are of integer type. The mode of operation is said to be integer mode and the result will be of integer type. Say for example, when I divide 4 divided by 3, the numerator is also of integer type and the denominator is also integer type, and the result will be equal to 1. Instead of 1.333, I will be getting the result as 1, which is also an integer type. So this mode of operation is integer mode. Next we have floating point mode. Here both the operands are of floating point type. The mode of operation is said to be floating point mode and the result will be of floating point type. Say for example, when I divide 4.0 by 3.0, the result will be equal to 1.333. Here the numerator is also a floating point number and the denominator is also a floating point number and the result also is of the same type. This is called as floating point mode. Then we have the mixed mode. One operand is of integer type and another operand is of floating point type. The mode of operation is said to be mixed mode. The result will be of floating point type, the higher data type. So we have 4 numerator which is of integer type and the denominator is 3.0 which is floating point type. The result will be of floating point type 1.333. That is what we will be getting as the result, which is the higher data type. These are the three modes of operations. Relational operator. So the relational operator includes less than, greater than, less than or equal to, greater than or equal to, and not equal to. So for equal to, we have to use double comparison operator. So it is not single operator. So if it is single comparison, then it is assignment operator. So here for equal to, we have to use double comparison operator. Any expression containing a relational operator is termed as a relational expression. The value of a relational expression is a Boolean constant. That is, either it will be 0 or 1. If the specified relation, or which means that if the relational expression evaluates for true value, then its equivalent value is 1. If it is false value, then its equivalent value is 0. So these are few examples. Say for example, if I consider the value of A is equal to 10 and B is equal to 5, the first example A greater than 5, which means that 10 greater than 5. So the value which I will obtain is a true value which is equivalent to 1. Similarly, for the next example also, A less than B, which means that 10 less than B. Here the expression evaluates for false. 10 less than 5, which means that it is a false value. So the value is equivalent to 0. Logical operator. The logical operator includes logical NOT, logical and logical OR. Logical NOT is a unary operator. It is applied for a single operand. An expression which combines two or more relational expressions is termed as a logical expression or a compound relational expression. These logical operators are applied on a relational expression. It's applied on a combination of relational expression. The truth table is a reference for performing this logical operation. So let us discuss with the example. Say for example, the expression E1, logical AND E2. So what will be the result? If E1 evaluates to a true value 1 and E2 evaluates to a false value 0, then the resultant of this logical expression will be 0. You can see the truth table. If A value, the operand A value is 1 and the operand B value is 0, the result will be 0. Similarly, it is applicable for other values also. So, if the operand A is 0 and the operand B is 0, logical AND value will be 0. If the operand A is 0 and the operand B evaluates to 1, the result of the logical AND operation will be 0. If the operand is 1, A operand and B operand is also 1, the logical AND value will be 1. Similarly, you can refer to this truth table for logical OR operation and NOT operation. So, in NOT operation, it just toggles the result. Suppose if you are getting the result as 0, the output will be 1. If the result of the expression is 1, the output will be 0 when we are using a logical NOT. Bitwise operators includes bitwise NOT, left shift, right shift, bitwise AND, bitwise XOR and bitwise OR. The operators do not consider the operand as a single entity here and they operate on the individual bits of the operands. These bitwise operators, they operate on the individual bits of the operand and they do not consider the operand as a single entity. Here bitwise NOT is a unary operator, which means that it operates on a single operand. The truth table gives the reference for performing XOR operation. Let us discuss with one example. 2 bitwise AND 3. Let us see how this bitwise operation is performed on this 2 and 3. Suppose if it is a logical operator, then this 2 can be considered as a single entity, that it will be considered as a non-zero value and the operand is considered as true. 3 is also considered as a non-zero value and the operand is considered as true. But in bitwise operation, it is not like that. The 2 will be converted to a binary value. 3 will also be converted to a binary value, equivalent binary value. And bitwise AND operation is performed on the individual bits of this binary value to get the result. So you can see the equivalent value of 2 is 0, 0, 1, 0. The equivalent value of 3 is 0, 0, 1, 1. You need to perform the AND operation on the individual bits of 2 and 3. So the result will be 0, 1 will give you 0, 1, 1 will give you 1, 0, 0 will give you 0, 0, 0 will give you 0. So you can refer to the truth table, previous truth table. So the equivalent value of the result, binary equivalent value, you are getting as 0, 0, 1, 0 and the equivalent value is 2. So that is the answer. So 2 bitwise AND will give you an answer as 2. So this is how bitwise operations are performed. Let us see one example for bitwise NOT and left shift operator also. First we will see for bitwise NOT. Consider this example tilde 2. So what will be the output when you are performing bitwise NOT? First you have to take the equivalent binary value of 2, which is 0, 0, 1, 0 and then we have to perform the bitwise NOT, which means that we have to toggle the input. So first 0 it gets toggled to 1. For 1 it becomes 0. Again for 0 it becomes 1. For 0 it becomes 1. So the equivalent value for this is 13, which is the result for tilde 2. Next we will see an example for left shift operator. For left shift 1. So first we have to write the equivalent value of 4. 0, 1, 0, 0. Then shift the bits by 1 position to the left. So it will become 1, 0, 0 and the last you have to add a 0. So now the equivalent value for this is 8. So that will become the result. So this is how bitwise NOT and shift operations are performed. Next is the assignment operator. A variable can be assigned a value by using an assignment operator. The assignment operator is indicated by a single comparison operator. All the arithmetic operators can be combined with this assignment operator as well as bitwise AND, bitwise OR, bitwise XOR, and left shift and right shift operators can be combined with this assignment operator. Here in the example you can see we have A is equal to 10, which means that the variable A is assigned a value 10. The second example we have A plus equal to B, which is equivalent to A is equal to A plus B. Here, instead of repeating the A operand twice, we are denoting in a shortened notation A plus equal to B. So this type of assignment we call it as common assignment operator. In special operators, we have function call operators. They are used in defining and calling the functions. Array subscript operators are used in accessing the elements of the array. Direct number access operator and indirect number access operators are used for accessing the elements in structure and union. The indirection operator and address of operator are used in pointers. The conditional operators, which we have already discussed, so it is the only ternary operator. The general form is E1 question mark E2 colon E3, where E1, E2 and E3 are sub-expression. So the sub-expressions will be evaluated first. So if E1 evaluates to a non-zero value, that is, which means that if it is a true value, then E2 will be evaluated. Suppose if E1 evaluates to a false value, then E3 is evaluated and E2 is ignored. Then we have the comma operator. It is used to join multiple expressions together. So the comma operator, it does left to right evaluation. The result and type of the overall expression is the value and type of evaluation of the rightmost sub-expression. Say for example, if you have value is equal to x is equal to 10, comma, y is equal to 5, comma, x plus y, then the value will evaluate to 15. Every instance of a comma symbol is not a comma operator. The commas appearing between the arguments in a function call or in a declaration or a function definition statements, they are called as separators. Then we have the size of operator. So this is used to determine the size in bytes, which a data object will take in memory. Say for example, if I say int a is equal to 1 and assign a variable, integer variable b, and if I say b is equal to size of a, then size of a will be 2 bytes, which means that integer occupies 2 bytes in memory. So the value of b will be equal to 2. So that is the purpose of size of operator. The address of operator, it is used to find the address of a data object. So when we are applying it in the program, so they are given to the left side of the operand. The operator will appear to the left of its operand. Now let us discuss about operator precedence and associativity. Consider this expression a is equal to 2 plus 3 into 5. In this expression, which sub-expression will be evaluated first? Whether 2 plus 3 will be evaluated or 3 into 5 will be evaluated. So this is where operator precedence comes for the rescue. Operator precedence is used to determine how an expression involving more than one operator. Say in this example, we have two operators, plus and multiplication. So more than one operator is evaluated. That will be decided by the operator precedence. Each operator in C has a precedence associated with it. Operators which are at the higher level of precedence is evaluated first. So according to that, the sub-expression 3 into 5 will be evaluated first, as multiplication operator has higher precedence among equal to, plus and multiplication operator. So 3 into 5 will be evaluated to give 15. Then 2 plus 15 will be evaluated, which will give you the result as 17, and that will be assigned to A. We saw what is operator precedence. Then what is associativity? So consider this example. A is equal to 5 plus 3 minus 5. So here, which sub-expression will be evaluated first? Whether 5 plus 3 will be evaluated or 3 minus 5 will be evaluated, because plus and minus are the same level of operator precedence. They have the same priority. So which sub-expression will be evaluated first? So this is where associativity plays a major role. In a common expression, when several operators of the same precedence appear together, the operators are evaluated according to their associativity, which means that it can be either from left to right evaluation or it can be from right to left evaluation. The highest precedence level is 1 and the lowest precedence level is 15. Precedence rule will decide the order in which the different operators are applied. Associativity rule decides the order in which multiple occurrences of the same level operators are applied. So according to associativity, the addition and subtraction operation, they have associativity from left to right, which means that they start evaluating from left to right. So we have plus and minus. If operators of the same precedence are available in an expression, we will be evaluating from the left side, which means that 5 plus 3 will be evaluated first. So which will give you a result as 8, and then 8 minus 5 will be evaluated, which will give you the result as 3. The table shows the operator precedence and associativity. So the operators at level 1 has the highest priority, and so on. We have till level 15. The operator at level 15 has the lowest priority. So if you can see here, we have parenthesis for grouping, subscript, array subscript operator, member access operators, which are at the highest level of precedence. Comma will have the lowest level of precedence. The associativity for each operators are also given, whether we have to evaluate from the left to right or from the right to left. So for arithmetic expression evaluation, this operator precedence and associativity rule is followed. Let's now try to evaluate an expression by using the operator precedence and associativity rule. X is equal to A minus B slash 3 plus C into 2 minus 1. Let the A value be equal to 9, B is equal to 12 and C is equal to 3. First step, we will apply the values of the variables to the expression. So this is an arithmetic expression. We will apply the value which is assigned to these variables to the expression. So it becomes X is equal to 9 minus 12 by 3 plus 3 into 2 minus 1. So here, which sub-expression will be evaluated first? So we have minus, we have division plus multiplication and then minus. So according to the operator precedence rule, division and multiplication has the higher priority. But we have both the operators in this expression. Whereas the associativity rule says that we have to execute from left to right. So according to that rule, division has to be operated first. So 12 by 3 will be evaluated first. So we will get the result as 4. So the expression now becomes as 9 minus 4 plus 3 into 2 minus 1. So next, it will perform the multiplication operation. So it becomes x is equal to 9 minus 4 plus 6 minus 1. So now we have the subtraction and addition operators. So both are in the same level of priority according to the operator precedence rule. So it will apply the associativity rule. So when we have the same level of precedence, we need to see the associativity rule. So from where we have to evaluate, again from left to right. So the sub expression 9 minus 4 will be evaluated. So there you will get the result as 5. So it becomes x is equal to 5 plus 6 minus 1. So now again the sub expression 5 plus 6 will be evaluated according to the associativity rule. So x is equal to 11 minus 1. So finally we get the result as x is equal to 10. So this is how you have to apply the operator precedence rule and associativity rule in evaluating an expression. In this video, we discussed about operators, its precedence and associativity. In the next video, we will focus on variables and data types. Hope this video was useful to you. Please don't forget to subscribe, like and share. We will meet in the next video. Thank you.